share with you my thoughts about Luca. I regard him as a true Renaissance man, able to understand and make original contributions in a huge range, not just of scientific areas, but also in the social sciences. You've heard about his contributions in bacterial genetics, in phylogeny reconstruction, in human population structure and migration, in human genetics, and its comparison with linguistics, where he wrote a number of very important papers. And of course, in human origins, and among the most important things that I had the good fortune to work with him on, the evolution of culture. And finally, his wonderful contribution to Italian culture. Luca, I met for the first time when he was visiting Walter at Stanford between 1968 and 1969, and I was a PhD student. Walter Bodmer was one of my two advisors. The other was a professor in the mathematics department. And I arrived at Stanford very shortly as a new assistant professor, very shortly after Luca had moved to Stanford. And it was a fantastic coincidence. He joined the genetics department in 1971. I arrived at Christmas of 1971. Luca joined the genetics department, and eventually he became chairman of that department, a duty he hated. One of the things Luca really disliked was administration. And when one time he told me he was so happy that David Botstein became chairman because they never had any faculty meetings, which he regarded as an incredibly good thing. He hated going to meetings. We have, in 2005, the Genetic Society of America asked me to participate in an interview series which they had called The Great Geneticists. You went to medical school very young.
I was 16 when I went to medical school in Turin the first year. And then after doing the first year there, well, I had some, which was a very good university, but I had a scholarship in Pavia, which is the only Italian university that has colleges like Oxford or Cambridge in England. And I chose to go there.
Why did you choose medicine to begin with?
Well, when I graduated, I really had no idea what to do. And I was in England to learn English in the summer before choosing university. And I discovered, I saw the first microscope I ever saw in my life, because I went to a course that was at the University of Exeter. And I saw microscopes, and I was fascinated by microscopes. And I also felt at this stage that medicine might be an interesting way to learn to know about people. So I was queuing for registering in medicine, and I discovered there was another faculty which I didn't know, called Faculty of Natural Sciences and Biology. And I thought, oh, maybe I should go there. But the idea of going on another queue and writing again all my documents for registering, I thought, well, maybe I'll change afterwards. So I stayed in medicine. And that really may have saved my life, because when I was a student, a medical student, the war broke in Italy in 1941, and Italy entered the war 1 year later. And so I was not conscripted, because Italy decided it wanted to keep medical students. It needed to have more doctors. Mm-hmm. So I did not have to fight.
Yeah, but during that medical school, you became interested in bacteria.
Yes, that was my first love in research. I was very challenged when I studied bacteriology to see that people thought that it was impossible to measure virulence. I thought must be possible to measure virulence, must be possible to measure everything. I didn't know much statistics. In fact, I didn't know any, and I decided I had to learn it, and I became fairly proficient in it. And so we started making attempts at measuring virulence.
In 1972, I was at a seminar series at Stanford, originated by my two thesis advisors, Walter Bodmer and Sam Carlin, and Walter had already left for Oxford. This seminar series was called Mathematical Population Genetics, and it was in the winter of 1972, the early part of the year. And Luca gave his first talk at that seminar. I was there, and I had some problems with the mathematics. And Luca, I asked him about it during the seminar, and he asked me to come to his house. And from that point on, for the next 35 years, we met 3 nights a week and 1 afternoon in the weekends, working on cultural evolution. The first papers came in 1973. The book from Princeton University Press came in 1981, but in between, Luca had some major health problems. And one of my most important memories of Luca after surgery in 1976, when he was in hospital, he asked me to come to work with him. And we were working on part of the book on cultural evolution while he was lying in hospital with drips coming down into every part of his body. We traveled together, and my wife, Shirley, who's a professor of psychology, loved to travel with Luca. And the reason is, she says, is because whenever we had guides, Luca knew so much more about every place we went than any of the guides. It was so much fun to travel with Luca. We went to Taiwan together, and we visited with Taiwanese Aborigines. I remember the police coming to us afterwards, and the military, and telling us, you can't say that, you cannot say that the Taiwanese Aborigines are Melanesian because they're Chinese. They're not allowed to be Melanesian. And in Japan, when we traveled, he knew so much more about Japanese origins, the Jomon culture and other things, than any of those guides that we had there. And the third trip we took together was to my hometown in Perth, Australia. And we met there with the head of the Aborigines and Torres Strait Islanders population, because we wanted to ask them to give us some DNA samples so that we could include them in the Human Genome Diversity Panel. And I remember Luca's absolute shock when this chairman said, well, how much money do you have? They really wanted a bribe, and we didn't have any grants, we didn't have any money, so we couldn't. And that's the reason there are no Aborigine from Australia, no Australian Aborigine samples in the Human Genome Diversity Panel. He also originated the idea of the serial founder effect, which is the idea that a small sample of people left Africa, moved to Europe and Asia, and that there was continual sampling of the populations that moved, which would lead to a drop in the amount of genetic variation. It's a simple mathematical rule of sampling from sampling from sampling. And we showed eventually mathematically what this would lead to. And then when the Human Genome Diversity Panel was finally formed, and we started, Luca actually, was an idea he'd had a long time before. The first meeting to produce the Human Genome Diversity Panel took place at Stanford early 1991. And from then on, we tried to get funds for the Human Genome Diversity Panel. And you will see in the next film Luca's discussion of that.
the National Institute of Health generated a committee of the National Research Council that took 3 years to decide whether the Human Genome Diversity Project should be done.
Mm-hmm.
But at the time they had decided yes, with some precautions, we had already decided to start at a meeting that took place in the first symposium on human evolution that was promoted by Jim Watson in Cold Spring Harbor, in which we invited all the people who had made cell lines like I had on 11 populations, and to donate the cell lines and to donate them at an institute in France called the Center for Study of Human Polymorphism, CEPH. It has been founded by Jean Dosset, a great scientist, Nobel Prize for the discovery of HLA. And it took 11 years, but we made it. Mm-hmm. And today there are 81 laboratories that have used it. The first that made a paper also published the most important paper. And I'm very glad to say that this was done by Mark Feldman, who is just in front of me. I'm most grateful to him. He did a very good job.
Then one of your great ideas about testing out of Africa, we use the same data again to check statistically.
Yes.
Right.
And this is the work we just published.
Yes.
We looked at the similarity that there is between the genetic distance between populations for a very large number of markers.
About
780 markers, each of which has thin forms, so it's about 8,000 alleles. And we looked at the similarity, the correlation between the genetic distance based on those markers and the geographic distance. And it came out a correlation of 0.89 with a maximum of 1, which is the highest correlation I have ever seen calculated in biology, which probably means that drift is very important.
So Luca's legacy of how to study human genomic variation around the world, there may be papers that you will see in the literature today, but there is no question that the way in which they approach the problems of studying human genetic and genomic variation around the world has its origins in Luca's thoughts and in the papers that he published. And in the next few months you will see those ideas coming to a new fruition, where you'll see some papers coming out that show that the genomics of the peoples of Easter Island in the remote Pacific actually share identity by descent with genes from the Peruvian Andes. And it's the techniques that I used in that paper are exactly the techniques that Luca used throughout his career. A great scientist and a great person to collaborate with. After 40 years of collaboration, it's my great privilege to thank Luca.